So good evening, and I hope everyone is fine there. So tell me, is audio and video clear? Tell me, guys, am I audible? Please comment in the chat section. Please reply in the chat section. Tell me, guys, am I audible? Sir, mains preparation, any course from BYJU'S? Yes, Nachiket. Yes, you will get the course for main preparation and mains preparation. So you can talk to the BYJU'S. I mean the help desk. You can call at the number, and you can easily get that course. Okay, so you can prepare from that course. So it's available on BYJU'S. Don't worry. Good evening, sir. Sir, audio and video clear. Okay, thank you, Deepa. Thank you. Sir, at present VLSI or AI, which is best? I think AI and VLSI both are good, okay, but the future is AI, okay. Even the VLSI is again important, but AI is again, it will sustain for more time, okay. So both are good, okay. Madhu, okay, audio is clear. Thank you, Aryan. Thank you. So let's start the session, guys. Let's not discuss other thing. Okay, so let's start the session. And in the previous session, I was discussing about the equivalent resistance, how to calculate equivalent resistance. So there were 2-3 things that I have discussed with you. Equivalent resistance using path method, and then I told you about equivalent resistance of infinite ladder, and then I discussed about balanced bridge, Wheatstone bridge. Okay, those 3 things I have already discussed. Now in this session, we will discuss about unbalanced bridge, and there is one more case, that is equivalent resistance of symmetric structures, symmetric geometry. Okay, that we will discuss, but not in this lecture. The symmetric structure I will discuss after nodal analysis, because after nodal analysis you will understand it easily. Okay, because there are some few concepts which are important in symmetric structure. How to calculate current and voltage, and how to check using voltage and current. So that thing can be understood after nodal. So after nodal, I will discuss about the equivalent resistance of symmetric structure. So I'm going to leave that part for the time being. So in today's class, we'll discuss about equivalent resistance using star delta conversion, and then we will proceed with the basic laws. Okay. So I think it's time to start, guys. सर आपकी इस सीरीज को फॉलो करने से सब्जेक्ट कंप्लीट हो जाएगा या एक्स्ट्रा कुछ फॉलो करना पड़ेगा? एक्स्ट्रा कुछ नहीं फॉलो करना है, यू जस्ट फॉलो दिस सीरीज एंड आपका नेटवर्क थ्योरी कंप्लीट हो जाएगा. ओके, बट द थिंग इज आई नीड द प्रेजेंस, आई नीड द अटेंडेंस. इफ योर अटेंडेंस इज गुड, आई विल कंटिन्यू. If your attendance is not good, I have to stop the series. Okay, so that is the only condition. Okay, so let's start the session, guys. Let's start. So this is my introduction, guys. Those students who don't know me, my name is Asu Jangda, and I teach almost every subject in electrical engineering. Right now I'm teaching network theory. Okay, I hope you're enjoying network theory. This is fundamental series, and we are also going to start one more series, that is BARC 2023 Super 15 series. Okay, in Super 15 series we will discuss about some questions and something. So the starting of this series will be on 10th of March. Okay, so you can start this series with us. It will be helpful in BARC exam. Okay, there is one free workshop which will be on 9th of March at 7:30 p.m. and this workshop will be taken by Richa Gupta ma'am, and you can join this session, and in this session you will understand about GATE 2024, what to do and what not to do. Okay, so that is important. So you can join this workshop, you can register for this workshop. Link is given in the description. Those students who have not subscribed our channel, please subscribe it and press the bell icon so that you get the notification whenever my lectures are live. And please like this session so that it's kind of Guru Dakshina. Okay, so don't forget to like this session. Okay, guys. So I think it's time to start. But before starting, let me tell you guys, in the previous class we have discussed about star delta conversion. I think I just told you that in unbalanced bridge we require star delta conversion, but in balanced bridge you don't require star delta conversion. Let's start from the previous class only. So in the last class I told you something about the bridge. let's say you have a bridge like this. Let's say you have a bridge like this. There is a bridge and the bridge is like this. Let's say this is R1, R2, R3, R4. And there is a bridging branch R0. This point is A and this point is B. Now let's say you want to calculate RAB. How to calculate RAB? How to calculate RAB? I told you that this bridge will be balanced. We call it Wheatstone bridge. If R1 upon R2, the connected resistance ratio, okay, the connected resistance ratio, R1 upon R2, if R1 upon R2 is equal to R3 upon R4, if this condition satisfies, R1 upon R2 is equal to R3 upon R4, or you can say R1 upon R3 is equal to R2 upon R4. If this condition satisfies, then you can remove this R0, we call it balanced bridge, you can remove this R0. If R0 can be removed, then R1 and R3 will be in series, R2 and R4 will be in series, and these two branches will be in parallel, okay? R1 plus R3 in parallel with R2 plus R4. So you can take their parallel equivalent and you can calculate the equivalent resistance. I hope it is clear, okay? So in the previous class, we have discussed that. But I told you that if the bridge is not balanced, then we need to understand star-delta conversion. Okay, then we need to understand star-delta, star to delta and delta to star. If you know this conversion, then it will be very easy to solve such questions, whether the bridge is balanced or unbalanced. If you know this conversion, it will be easy for us to understand and to solve these questions. I have also given you the one homework question. So I will discuss that question at the end of the class, okay? So let's start with the star-delta conversion first. Let's say the resistances are given in star form. This is called star form. This is called star and this is called delta. This is my star form and this is delta connection. Now, let's say this resistance is RA, this resistance is RB, and this resistance is RC. And it is provided to us. Let's say three resistances are connected in star form. Okay? And we need to convert them in delta. We call it RAB, we call it RBC, and we call it RCA. And we want to convert from star to delta. Okay? Now, how to convert from star to delta? It's very easy. First, you have to understand how to calculate these values, because these values are important. The proof I will tell you later. Proof is not important as far as gate is concerned, okay? But for ESE, you need the proof. So let's not discuss about proof, how to remember these. First, let's discuss how to remember that. And then if you insist me, then obviously I will tell you the proof also. Okay, so let's discuss RAB first. How to calculate RAB? If these are provided to you, let's say RA, RB, RC are known to us. They are given to us. We need to calculate RAB. Now, how to calculate RAB? So RAB will be equal to, you need to just apply some trick, and the trick is RAB is connected between point A and B. And between point A and B, there are two resistors. A is connected with RA and B is connected with RB. So you can say that it will be RA plus RB plus RA-RB divided by RC. So you can directly remember that, okay? Because we need to calculate RAB. RAB means the resistance between A and B. Now, if you look at this connection, between A and B, there is one RA and there is one RB. So what you can do is, you can calculate RAB as RA plus RB plus RA-RB divided by RC. Similarly, you can calculate RBC. Tell me guys, what is RBC? So RBC will be equal to, since RBC is connected between B and C, and between B and C you have RB and RC. So it will be RB plus RC, RB plus RC plus RB RC divided by RC divided by RA. Okay, this way you can calculate RBC. Similarly, you can calculate RCA. Okay, RCA is connected between C and A, so it will be RC plus RA plus RCRA divided by RB. I hope it is clear. Okay guys, so this way you can convert from star to delta. If the resistances are given in star, you can easily convert into delta. This is also called T to pi. This is also T, we call it T network like this. This is again, you can also call it T. This is A, this is B, and this is C. Inverted T, you can say. This is like T, na? Or I mean, there are so many ways to represent this T. Okay, now you can convert this in pi. Wait a minute. Let's make it like T. Let's make it T like this. Okay, so we have this A, this B, and this C. Okay, this is RA, this is RB, this is RB. We also call it T network. And we can convert it into pi. Pi means like this. This is my pi network. Pi is again a delta network. Okay, this point is A, this point is B, and the lower point is C. So actually these two resistors were connected like this, so I have separated them out. So we call it T to pi. T to pi network. Okay, so don't confuse with the pi network. Pi network is again a delta network. Okay, pi network is also called the delta network. I hope it is clear. So from star to delta, you can easily remember like this. I have told you with the help of subscript or the connection, because you can see that this resistance is between A and B, so you can directly pick these two resistance between A and B, multiply them and divide by the third resistance. So it's very easy. Okay, now what if we know the delta connection and we need to convert the star? Okay, now from delta to star, how to convert from delta to star? Now let's say you know this is known to us, RAB, RBC, and RCA. Let's say we know this. We know this. RAB, RBC, and RCA. It is provided to us. And we need to convert in star. How to convert it into star? Tell me, guys. How to convert this delta into star? We need to calculate RA. We need to calculate RB and RC. How to calculate these three resistances? RA, RB, RC. If you know these three things, three resistances, we need to calculate this. Now, again, it's very easy. Let's first calculate RA. Now, you can see that RA is connected at A. RA is connected at A point. And if you look at this circuit, in this circuit, at point A, there are two resistances, RAB and RCA. So what you can do is you can multiply them, RAB into RCA divided by RAB plus RBC plus RCA. So you can easily remember this. Similarly, let's say you want to calculate RB. RB is connected at point B. And at point B in this circuit, there are two resistances, RAB and RBC. So it will be RAB into RBC divided by the sum of the three resistances, RAB plus RBC plus RCA. I hope it is clear. Tell me, guys. I hope it is clear. So we have calculated RB. Similarly, we can calculate RC. Similarly, we can calculate RC like this. RC is connected at point C, and at point C, there are two resistances, RBC and RCA. So it will be RBC into RCA divided by RAB plus RBC plus RC. I hope it is clear. So this way, you can calculate RA, RB, and RC. Okay? And you can easily remember that because it's very simple. Now, let me tell you one more point, and that point is important that you need to remember. Let's say you want to calculate in this star side. Let's say we have a star side. We have a star side. Let's say we have a star side and we have a delta side. Now, let's say this is 1 ohm or maybe 3 ohm. This is 3 ohm and 3 ohm. Can you calculate these values? Tell me, guys. A, B, C. Tell me what is RAB, what is RBC, and what is RCA. So remember, this ABC, the location of ABC is same like this, because the relative location of A, B, and C should be same. A is in this side, so B is in this side from A. So I have connected like this only. Okay. So I'm not changing the position of ABC point. The point should be same. Okay. Now, if these resistances are provided to you, 3, 3, 3. Now, what is this resistance? Can you tell me, guys? What is this resistance? Can you calculate this? Again, it's very simple. What you can do is, this resistance is connected between A and B. So, RAB will be equal to, tell me, 3 plus 3 plus 3 into 3 divided by the 3. Okay, so it will be 9 ohm. It will be 9 ohm. I hope it is clear. Okay. And we know that if all the resistances are equal, these resistances will also be equal. This will also be 9 ohm. This will also be 9 ohm. So it's very easy. It's very easy to calculate. I hope you understood. Now, the important point is, let's say, we know that these two circuits are equivalent to one another. They are equivalent to one another. Now, if you want to calculate the equivalent resistance between A and C only by keeping B open, if you want to calculate equivalent resistance between A and C, can you tell me what is the equivalent resistance between A and C on this side? Equivalent resistance between A and C on this side. So it will be 3 plus 3. This 3 will not be in the equivalent of equivalent resistance between these 2 points. Okay. So if you want to calculate between A and C, the equivalent resistance has to be 6 ohm because this is open. This is 6 ohm. Now, the same thing you are doing in this circuit. You can check that if you want to calculate the equivalent resistance between these 2 points, it will not be 9 ohm. It will be 9 ohm in parallel with 18 ohm. So, the 9 and 18 you have to take parallel. Okay. So, it will be again 6 ohm. So, you can check. You can check that since these two branches, these two circuits are equivalent to one another. So if you want to calculate equivalent resistance between A and C on this side and A and C on this side, you'll get the same answer. Okay, you'll get the same answer. 6 ohm on this side and 6 ohm on this side. Okay. Similarly, you can calculate equivalent resistance between B and C. By keeping A open, you can calculate equivalent resistance between B and C. So it will be again 6 ohm. Similarly, you can calculate equivalent resistance between B and C by taking 2 points out. So it will be 18 ohm in parallel with 9 ohm, you will get the 6 ohm. Okay, I hope it is clear. This point is very important and we will use it in the next, maybe in magnetically coupled circuit, we will try to use this concept. Okay, I hope you understood it. Okay, सरफेस सर्किट में इक्विवेलेंट 6 फिर से बताइए. देखिए दोस्तों, जब भी आप A और C के बीच में इक्विवेलेंट निकालना चाहेंगे तो ऑब्वियसली आप B को रिमूव कर दीजिए, B को कनेक्ट मत कीजिए. आपको इक्विवेलेंट रेजिस्टेंस चाहिए बिटवीन A एंड C और आप स्टार साइड निकाल रहे हो तो आपको क्या करना है, B को ओपन छोड़ दीजिए और यहाँ पे 2 पॉइंट ले लीजिए. इनके बीच का इक्विवेलेंट निकालोगे तो कोई करंट फ्लो होगा ही नहीं. अगर सोर्स लगाओगे तो केवल इस पाथ में करंट फ्लो होगा. सो इक्विवेलेंट रेजिस्टेंस हैज टू बी 6 ओम. सिमिलरली इन दिस साइड अगर A और C के बीच में निकालोगे आप तो 9 ओम इन पैरेलल विद 18 ओम. सो यू विल गेट द 6 आंसर. ओके, सो आप इस तरह से भी आप इनको देख सकते हो कि दोनों इक्विवेलेंट है एक दूसरे के, दोनों एक दूसरे के इक्विवेलेंट है. ठीक है, आई होप इट इज क्लियर. अब आप बोलोगे सर आपने ये पॉइंट क्यों बताया, क्योंकि ये पॉइंट जरूरी है. ये पॉइंट आगे चल के आप देखिएगा बड़ा इंपॉर्टेंट हो जाएगा आगे चल के. ठीक है, सो दैट्स व्हाई यू शुड नो कि भाई अगर इधर से हम 2 पॉइंट के बीच निकालेंगे और इधर से भी 2 पॉइंट के बीच में निकालेंगे तो सेम आंसर आएगा. सिमिलरली यहाँ पे 2 पॉइंट के बीच अगर आप रेजिस्टेंस निकालोगे और यहाँ पे भी दोनों पॉइंट के बीच रेजिस्टेंस निकालोगे तो सेम आंसर आना चाहिए. ओके, सो इट्स सिंपल. द नेक्स्ट थिंग इज, अगर ये बराबर है, इफ दीज 3 रेजिस्टेंसेस आर इक्वल देन दीज 3 रेजिस्टेंसेस विल आल्सो बी इक्वल. ये भी इक्वल आएंगे आपके. ठीक है, सो इसको भी आप ध्यान रखिएगा. नाउ लेट्स कम टू दिस प्रॉब्लम. Let's say we have some bridge connection and in that bridge the bridge is not balanced. So how to calculate the equivalent resistance? Let's say the circuit is like this. अगर मैं बोलूं कि सर्किट मेरा कुछ इस तरह का है, let's say this is 9, 6 and 18. Okay, now can you tell me whether this bridge is balanced or unbalanced? Tell me guys, is this bridge balanced or unbalanced? Obviously this bridge is not balanced. Why not? Because you can see that 9 upon 9 is not equal to 6 upon 18. So this bridge is unbalanced. Now if this bridge is unbalanced, how to calculate the equivalent resistance between A and B? It's easy. What you need to do is, you have to apply this star delta conversion. You have to find either delta or star, because there are also star connection in this point, in this bridge, and there are also deltas. How many delta you can see? Tell me guys, how many delta you can see in this circuit? How many delta you can see in this circuit? Actually, you can see that this is delta. This is a delta connection. These three resistors are connected in delta connection. Is it correct? Similarly, on this side, this is delta connection. You can see that this is again a delta connection. So you can convert these two deltas, I mean either delta, you have to take one delta, either this delta or this delta in star connection, okay? You can convert it into star and then you can proceed. There are also star points. Can you tell me how many star points are there in this circuit? Tell me guys, how many star points are there in this circuit? If you want to check the star, because there are some students who like star connection, star point. So there are also star point. Look at this point. This is a star point. There are three resistances connected to this star point. This is star point. We call it star point. Okay. At this star point, there must be three resistances. So there are three resistances. We call it A, B, and C, or whatever you call it. A, B, and this you can call C. So it's a star connection. You can see that these three resistances are connected in star. Only thing is, this resistance is not shown in upward direction. It is shown in downward direction. So it doesn't matter. Okay. Whether you show this 9 ohm in the upper side or on the lower side. So it's a star connection. Similarly, you can see that this 9, 18 and 9, this is also in star connection. So actually there are two stars and there are two deltas. Now, I want to convert delta into star. Okay, you can also convert star into delta. It's your choice. But I prefer, because I can see delta on this side and delta on this side. So you can use delta to star conversion. Okay. Now, if you want to convert delta to star, which delta you want to select? This delta side or this delta side? Tell me guys. Side 1 or side 2? Which one is easier to convert? Tell me. Which one is easier to convert? Side one side or the second side? Which side, which delta you want to select? Oh, side number 1 or side number 2? Which side you want to convert into star? Obviously, side number 1. Why? Why side number 1? Because in side number 1, all the resistances are equal. So if somehow you can calculate one star resistance, all the star resistances will be same. Okay, I hope it is clear. So let me erase this point. Okay. Now I want to convert this delta side into star. Now how to convert this delta side into star? It's very simple. You just make it like this. Okay, this delta can be converted into star. Now can you tell me this resistance value? This resistance value will be 9 into 9 divided by 9 plus 9 plus 9. It means 27. So it will be 3 ohm. Okay, so you can see that this resistance is 3 ohm. So this has to be 3, this has to be 3. Okay, so you can convert this delta into star and then you can remove this 999. This delta is removed. You can replace this delta with this star. So the net diagram will look like this. This is the star we have. 3, 3, 3. Okay, this side is A. Okay, we have 3, 3, 3, and after this 3 and 3, we have 6 and 18. Okay, so we have 6 and 18. This is 6 and here you have 18. I hope it is clear, and this point is B. Is it clear guys? Now you can simplify this and you can easily see that the equivalent you can easily calculate. This will be 9 ohm and this will be 21. So 9 in parallel with 21. 9 in parallel with 21. Okay. Is it clear guys? 9 in parallel with 21. So 9 into 21 divided by 30. In series with 3. So you just add 3. This will be my RAB. Is it clear guys? Is it clear? Tell me everyone. So you can convert delta into star. Sir, एक को convert करने से काम चलेगा? हाँ. केवल एक delta को convert करने से काम चल जाएगा. But there are some problems in which you need to convert two deltas into star. You need to apply the conversion 2 times or 3 times. So आप कितने times भी लगा सकते हो, it doesn't matter. Okay, it's up to you. You have to simplify the circuit. Okay, to simplify the circuit, you can apply star to delta conversion either 2 times or 3 times, or there is no requirement for the next time. No, only one time delta to star conversion is required. Once you apply this, the circuit will become very simple and you can easily calculate RAB. Okay. Yes. Let's come to the next question. Let's come to the next question and let's apply the same concept. Let's say I have a question like this. Let's say I have a question like this. And let's see how many of you can solve it. I will give you some time also. I will give you some time. This is a very famous problem. So let's try to solve this problem. Let's call it A and this B. And let's say this is 6, 6, 12. This is 6, this is 6, 6, 6, 6, 6. Okay. We need to calculate, this point is A, this point is B. We need to calculate RAB. But before solving this question, I want to tell you one more thing. Okay, I want to tell you one more thing before solving this question. Let's try to understand one more thing, one more important point. Okay, then I want to tell you, just be focused, please. Look at this. Let's say I have a circuit like this. I have a circuit like this. Let's see how many of you can think about it. Let's say this point is A and this point is B. There is one point A, there is one point B. So be careful. Let me use the different color so that it will not be mixed. So we have this circuit, guys. And in this circuit, what I have done is the values are important. So let's say this is A, this is B, and this resistance is 6 ohm, this is also 6 ohm, this is 9 ohm, this is 9 ohm, and this is 2 ohm. And we call it 9 ohm, we call it 18 ohm. Okay. Now my question is, how many of you think that this is a balanced bridge? And you can remove this 2 ohm. How many of you think that you can remove this 2 ohm because 6 upon 6 equal to 9 upon 9? Is it a balanced bridge? Tell me, guys. How many of you think that this is a balanced bridge and you can remove this 2 ohm? Just raise your hand. Okay. Or say why. If you are thinking why, if you are thinking like this, that you can remove it, you can say why in the chat section. And if you are not thinking like this, that this is not a bridge, this is not a balanced bridge, you can write N. You can write N in the chat section. Tell me, guys, how many of you think that this is a balanced bridge? Okay, Harshad is saying that this is a balanced bridge. Okay, and you can remove this 2 ohm. Okay, let's see the response of the other student. Yes. Senthil is saying yes. Abdul is also saying the same thing. Rishabh is saying no. Okay, Freeman is saying no. Okay. So there are some students who are saying, yes, you can remove this 2 ohm. Actually, the answer is no. This is not a balanced bridge. Why? Why it is not a balanced bridge? Because in balanced bridge, what happens is, let's say you have a balanced bridge. Let's say you have a balanced bridge. Or let's take an example. Let's take a circuit. Let's say you have a balanced bridge like this. Let's say this is 6 ohm, this is 6 ohm, this is 9 ohm, this is 9 ohm. In balanced bridge, what happens is, if you apply some voltage difference across these 2 points, let's say you applied some 20 volt or 30 volt, whatever. Okay, you applied some voltage difference between these 2 points. If you apply voltage difference between these 2 points, obviously the current will start flowing. The current will start flowing according to Ohm's law, because there is some equivalent resistance. So V upon R will be the resultant current. And that current will be divided into 2 paths. Let's call it I1, let's call it I2. I don't want to know these values, okay? But let's say that this current and this current is divided. If the bridge is balanced, whatever current is coming like this, the same current will go in this side. Okay, there will be no current in this resistance if the bridge is balanced. Okay, whatever current is in this branch, the same current will go in this branch. Okay, so there will be no current division at this point. But now in this circuit, if you look at this circuit, let's say this current is I. So this current is I1 and this current is I2. Now, how many of you think that if it is a balanced bridge, the same current will go in this side? No, sir. The same current will not go in this side. Why? Even if you are looking that this bridge is balanced, 6 upon 6 equal to 9 upon 9. So this bridge has to be balanced and there should be no current in this branch. But actually not, because the bridge will be balanced. I can remove this resistance only if this current and this current remains same. But actually it will not remain same. Why? Because there is one more branch. There is one more branch connected at this point. If there is one more branch connected, this I1 will be divided in this branch and this branch. And since this current and this current is not, this current and this current is not same, this current and this current is not same, you cannot remove this resistance. So there must be some current in this branch also. So there is a current division at this point. The entire current is not going in this 9 ohm. That's why you cannot apply balanced bridge condition here. Is it clear, guys? Tell me. Have you understood this point? Have you understood this point? This is very important. This is very important because many of you think that this is a balanced bridge, you can remove this too. The bridge will be balanced. You can remove this 2 ohm only if this current and this current remains the same. Whatever current is going on this side, the same current will go on this side. Okay? It means there is no current in this resistance, there is no current in this resistance. So you can remove this resistance as well as this resistance. But actually it is not the case. Whenever you have this type of connection, at the bridging point, not only 2 ohm is connected, there is one more resistance which is connected. Then you can't take the balanced bridge condition. You cannot apply the balanced bridge condition. I hope it is clear. Okay. So please be careful about this situation. Now, please try to solve this question. Now it's time to solve this question. We have a question 6, 6, 6, 6, 6, 6, 6. This is 12, this is 6, and this is 6. We need to calculate equivalent resistance between A and B. Let's put a timer. Let's put a timer. Okay. I want to put a timer. Okay. Let's put a timer of 2 minutes. Please try to solve this question. Try to solve this question. I want the answer. Do it fast, everyone. Do it fast. Let's see how many of you can solve it. So I have taken the timer of 2 minutes. Do it fast. Do it fast, everyone. Do it fast. Let's see how many of you can solve it. Okay, so you are asking उस पिछले क्वेश्चन को फिर करें कैसे? Okay, Sonu, I will tell you, because using this question, ultimately you will get to the same question. Okay. So using this question, I'll try to teach you. Don't worry, you'll get the idea, Sonu, because the same question will be converted into the previous question. That's why I have told you that. तो परेशान मत होइए, इस क्वेश्चन के हेल्प से पिछले वाली कंडीशन को भी हम समझ जाएंगे कि उसको सोल्व कैसे करना है फिर पिछले क्वेश्चन को. If the balanced bridge condition is not applicable, then how to solve the previous question? So using this question, we'll understand that. Don't worry. Try to solve this question, guys. Do it fast. Do it fast, everyone. Have you done it? Tell me, guys. Have you done it? Okay, time is over. Now it's my turn. Now I have already given you 2 minutes. Now it's my turn, guys. So let's try to solve this question. Again, it's very easy. So let me rub this part because I think this is not required now. So let's rub this part. Okay. Now in this question, first of all, try to find the series and the parallel branches. Can you see some series and the parallel branches? Yes. You can see that this 6 ohm and this 6 ohm, they are in series. So better you first start from this branch. You can say that this 6 ohm and this 6 ohm are in series. So you can connect them in series like this. Okay. So this is 12 ohm. We know that. And there is one more 12 ohm. Is it clear, guys? Tell me. There is one more 12 ohm. Now you can see that this 12 and this 12, they are in parallel. If they are in parallel, you can combine them and it will become 6 ohm. They have the same starting point and the same end point. So you can combine them. It will become 6 ohm. Now look at this connection. Is it a balanced bridge? Tell me, guys. Look at this connection. Is it a balanced bridge? Look at this connection now. Is it a balanced bridge? How many of you think that this is a balanced bridge? Tell me. Is it a balanced bridge? Say yes or no. Is it a balanced bridge? Tell me, guys. Is it a balanced bridge? Answer is no. This is not a balanced bridge. Why not? Because there is a current division at this point. The entire current will not go in this side. There will be current division here. Okay. So this is not a balanced bridge. Now how to solve this question? If this is not a balanced bridge, okay, yes, now this is not a balanced bridge. Now how to solve this question? We know that here you have delta. This is also a delta connection. This is also a delta connection. Actually there are 3 deltas. So we can apply star delta conversion. Because there is no series and no parallel resistances, you can see. You cannot say that 6 and 6 are in parallel. No. You cannot say that this 6 and this 6 are in series. No, you cannot say that. So now you are not able to find series and parallel resistances because there are no resistances which are in series and which are in parallel. Now what we need to do is we need to apply star delta conversion, whether you convert from delta to star or star to delta, because there are stars point also and there are delta points also. So now I want to convert this delta into star. You can also convert 2 deltas into star, this delta and this delta. They are isolated deltas. I mean, this delta has no connection with this delta, only the single point is connected. Okay. So you can apply 2 conversion, this delta and this delta. But you cannot take this delta and this delta because this branch is common. This branch can be taken in either upper delta or the lower delta. Okay. That's why I have taken it in the upper delta. That's why I cannot take this branch in lower delta also. I hope it is clear. So what I'm doing is I'm converting this delta into star and this delta into star. Okay. So let's convert this delta into star like this and this delta into star like this. I hope it is clear. Tell me, guys. I hope it is clear. Now let's redraw the circuit. So from A you have a star connection like this. Okay. Now tell me this resistance. This resistance will be 6 into 6 divided by 6 plus 6 plus 6. So it will be 2 ohm. I hope it is clear. If it is 2, this will be 2 and this will also be 2. Is it clear, guys? Now there is a 6 ohm. This 6 ohm and this 6 ohm, they are removed now. In place of these 6 ohms, we have 2, 2, 2. Okay. Now we have this 6. We have this 6 ohm. Okay. Now tell me about this delta. This delta is again converted into star. So this 6 gone, and in place of this 6 we have 2, 2, and so we have 2. There is one more 2 and there is 2. I hope it is clear. Tell me, guys. This point is B. Tell me, everyone, is it clear or not? Is it clear or not? So after this 6 we have this 2 and here 2 and this 2. Okay. So this is A, this is B. Now you can simplify this circuit. Now you can say that this part has 10 ohm resistance and this is 4 ohm. So this 10 and this 4 are in parallel. So 4 into 10 divided by 14. Okay. This is the equivalent resistance of this part. 10 in parallel with 4. So 10 into 4 divided by 14. And this equivalent resistance is in series with this 2 ohm and this 2 ohm. So plus 2 plus 2. I hope it is clear. Now you can calculate the answer. Tell me the answer, guys. Tell me the correct answer. So the correct answer will be 40 divided by 14 plus 4. Okay, 40 divided by 14 plus 4. I think you can calculate it. Tell me everyone, tell me what is the correct answer now. 4 plus 40 by 14. Is it clear? Okay. So this was the question and we have solved it using star delta conversion. So it is not necessary that you need to apply the star delta conversion only one time. You can apply it 2 times. Okay. In this circuit you have 2 deltas. So we have applied delta to star conversion twice. Okay. So I hope it is clear. Now it's time to move on. So I have covered this star delta conversion. I'm not telling you the proof. Proof you can explore at your own. Okay. I have given you some idea about the proof. I told you that you can prove it using that you calculate equivalent distance between A and C. Similarly on this side you can calculate equivalent distance between A and C and make them equal. Okay. Using that idea you will get some equations and you can prove it. Sir NTPC की जो नई लिस्ट आई है वो सिलेक्शन लिस्ट है या वेटिंग लिस्ट, क्योंकि वैकेंसी 800 है, लिस्ट में 2000 नाम दिए. आई डोंट नो भाई, मुझे इसके बारे में जानकारी नहीं है तुषार जी. सो प्लीज यू कैन चेक इट और मे बी यू कैन आस्क ऑन द टेलीग्राम ग्रुप. ओके, सो यू विल get the idea. Some student will tell you. Okay, so let's proceed guys. So I told you about star delta conversion. Okay. Sir, is duality rule important for gate? Yes, actually it is important, but I mean it is never asked in the exam. But if you know it, that's a good point. Okay. Sir, वो current वाला situation दोबारा बता दीजिए, bridge वाला. Okay, Sonu, I told you that जब भी ऐसे लगा हो तो ज्यादातर स्टूडेंट को ऐसा लगता है कि 6 6 9 9. So 6 upon 6 equal to 9 upon 9. So they think that this is a balanced bridge and they can remove this 2 ohm. No sir, this is not correct. Why it is not correct? Because जो करंट इस ब्रांच में आ रहा है वही करंट इसमें नहीं जा रहा है. अगर ये बैलेंस ब्रिज होता, in balance bridge the condition is there is no current in this resistance and whatever current in this resistance the same current will go in this side. Actually it is not happening here. Why not? Because there is one more resistance in this side. So out of this I1 current some current will go on this side, some current will go on this side. It means यहाँ का करंट और यहाँ का करंट सेम नहीं है. That's why you cannot remove it. इसमें भी कुछ ना कुछ करंट जाएगा फिर. This is not a balanced bridge condition. Okay, आपको इसको समझना पड़ेगा, इसको समझिए. Okay, let's come to the next point. Guys. So now I have covered the equivalent resistance calculation part. I have not covered one part, that is how to calculate equivalent resistance of symmetric structures, and that I will cover after nodal. Okay, because after nodal you will appreciate that part you will understand that part in easy way. Okay, so now let's come to the next thing, that is basic law. Now we are going to start with the basic laws. Okay, what is basic law? The basic laws are important in understanding current and voltage in the branches. Let's say there is some circuit. In that circuit there are some voltage sources, there are some current sources, there are some resistances, and you want to calculate the current in some branch or voltage across some branch or power loss in some resistance or power delivered by the source. So there are some specific rules that you need to follow. Okay, so in this chapter we will try to understand those rules. Now first thing is sources. We need to understand about the sources. Okay, so there are 2 sources, voltage source and current source. There are 2 types of sources, voltage source and current source. So first we will understand it one by one. What do you understand by voltage source? Voltage source can be of 2 types. Voltage source can be of 2 types. Voltage source, it can be of 2 types. One is independent voltage source, and there is one more type, dependent voltage source. Dependent voltage source. Okay, independent voltage source and dependent voltage source. Similarly, in current source also you have 2 types, dependent and independent. Dependent and independent. dependent and independent. Now the question is how to check whether the source is dependent or independent. Let's say you have a voltage source. The first thing is independent voltage source. So actually we will try to understand the independent sources only. Why? Why not dependent sources? Because the dependent sources will be covered in nodal. I don't want to teach these sources first, okay? First I want to teach you about independent sources. So independent voltage source, it can be shown like this. In a circle you have to show it. And there must be some polarity. There must be some polarity. Plus means the higher potential, minus means the lower potential, okay? Plus means the higher potential point, minus means the lower potential point, okay? So this is a independent voltage source. Let's say its value is 20. Its value is 20 volt. What does it mean? It means this is independent. It's not depending on anyone. Its voltage, the voltage difference between these 2 points is fixed at 20 volt. Upper point is at higher potential, lower point will be at lower potential, and its value is independent of some other parameter. Now look at this dependent voltage source. Dependent voltage source can be shown in the diamond shape. It will be like this, okay, and plus minus, and its value is dependent on some parameter. Let's say it is dependent on I1. It can be dependent on I1, it can be dependent on current or voltage, whatever, okay? So it's dependent. Now what is this I1 current? I1 current is some branch current. Which branch current? There might be many branches in a circuit. In a circuit, let's say there is some circuit, in that circuit there is some dependent source connected. That dependent source value is dependent on some I1. I1 is some branch current because there are so many branch current in that circuit. So on that branch current it is dependent. So we call it dependent source, dependent voltage source. The upper point is at higher potential, lower point is at lower potential. Okay, so it's a dependent voltage source. Similarly, you have current sources. Independent current sources can be shown in the circle, and the arrow will show you the direction of the current. Let's say this current is of 5 ampere. Now what does it mean? It means its value is independent, and this arrow will show you the direction in which the current will flow. Okay, 5 ampere. Similarly, you have dependent current source. Okay, let's say this value is dependent on I1 or some voltage. It can be dependent on anything. It can be dependent on current or it can be dependent on voltage. Okay, so you have dependent current source also. Dependent sources are shown in the diamond shape and independent sources are shown in the circle. Okay, now from this point onward we will try to understand only the independent sources. The dependent sources I will consider in nodal analysis. Okay, before that I will not consider them. So let's first discuss about voltage sources. Okay, let's first discuss about voltage sources. Now let's say we have a voltage source like this. There are some properties of this voltage source and its value is 20 volt, let's say. First of all, we have to understand what is the meaning of this 20 volt. The 20 volt is not the voltage of any point. It is actually the difference. Actually, you cannot define the point voltage. You cannot define the point voltage. Point voltage is not absolute. Okay. You cannot define a point voltage until unless you know the reference. Let's say I assume that this point is at 0 volt. If this point is at 0 volt, then this point will be at 20 volt. It means this source will maintain the difference. This source will maintain the difference. This will be at lower potential, this will be at higher potential. It means whenever you go upward, whenever you go from minus to plus, the voltage will be added. Okay, if you are saying that this is 0 volt, then this will automatically become 20 volt. But this is not absolute because it all depends on this value. If let's say this voltage is not 0 volt, let's say this voltage is 5 volt. Okay, I'm not making it ground. Let's say this voltage is 5 volt. If it is 0, then it has to be 20. But if it is 5 volt, then this voltage has to be 25 volt. It means voltage source will only tell you about the difference. It will not tell you about the point voltage. Okay, point voltage will depend on the reference value. Which reference you are taking. If you are taking this at 0, then this has to be 20 because you are going from minus to plus. If you are going from minus to plus, remember voltage will rise. Okay, voltage will rise. There are some students who follow the other convention. Actually, if you are going from minus to plus, they actually take it negative. Don't take it negative, okay? Whenever you're going from minus to plus, okay, you are moving upward. It means you are going from minus to plus. Then add the voltage, okay? If this is 0, this voltage is 20. This is difference. Remember, this voltage is difference, okay? This voltage is difference. It is not the point voltage. So if it is 0, this point will automatically be 20 volt, okay? Similarly, if it is 5, it will become 25. It means voltage source actually maintains the difference between 2 points. Voltage difference between 2 points. Whatever the value of the voltage source is, that difference has to be maintained between these 2 points. It is not a point voltage. Remember this point, okay? It is not a point voltage. It is telling about the difference between the 2 point voltages. I hope it is clear. Now, voltage source says that, let's say there is some circuit. Let's say we have some circuit, okay? And in that circuit, if I connect somewhere, if I connect across some branch or anywhere, okay, let's say this source is connected between these 2 points. Let's say this point is A and this point is B. In this circuit, there are 2 points and this voltage source is connected between these 2 points. Now, what this voltage source says, let's say this value is 20 volt or 10 volt, whatever, okay? This voltage source says that since I am connecting between these 2 points directly, there is no resistance in between, I am connected directly, so the voltage difference between these 2 points has to be equal to my value. If a voltage source is connected directly between the 2 points, then the voltage source between these 2 points will be equal to the voltage difference of the voltage value of this source, okay? This source will maintain the voltage difference across these 2 points because it is connected directly. I hope it is clear. So the voltage difference between these 2 points has to be 10 volt, okay? Because it is connected directly. Is it clear, guys? So a voltage source says that if there are 2 points and if I am connected directly to these 2 points, then the voltage difference between these 2 points will be equal to my value. That is 10 volt. It is the property of a voltage source. It will maintain the voltage difference between these 2 points equal to its own value, okay? Now the next thing is about current. This source says that I don't care about current. You can take any value of current from me, or you can also give current to me. I have no problem. It means there is no limit on the current. From the voltage source, you can take out some current according to the circuit demand, according to the Ohm's law. The circuit can demand any current depending on the equivalent resistance of this circuit. V upon R. V is the voltage difference. Voltage difference is 10 volt. Upon equivalent resistance of this circuit will be the current demand. So depending on this resistance value, current can be anything. So this source says, I don't care about current. You can take infinite current from me, or you can also give infinite current to me. I have no problem. So I don't care about the current. It means the voltage source doesn't care about the current. It does not apply any condition on current. Current can go from the voltage source or it can enter in the voltage source. It doesn't matter. Okay? Voltage source doesn't care about that. Only thing is the voltage difference. Okay? I hope it is clear. Now let's take a circuit. Let's say you have a resistance of 10 ohm and you have a 10 volt source on this side, and let's say you have 20 volt source on this side. Now can you tell me what is this current I? Find I. Can you find this current I? Tell me, guys. Can you find this current I? What is this current I? Tell me everyone, what is this current value I? Tell me everyone, what is this current value I? Try to find this current I. Tell me everyone, what is this current I? Can you tell me? What is this current I? Abdul is saying 3, okay. Anyone else? Sonu is saying not defined. Anyone else? Tell me everyone, what is this current I? What is this current I? Prashad, okay. Dr. Science 3. Okay, let me tell you guys. Now, there is a fight. Fight between these two sources. Why there is a fight? Because this source is connected directly at this point. This is single point. There is a straight wire, no? There is no resistance. It means it's a single point. This is also a single point. Now look at this source. This source is connected between these 2 points. Now what this source will say that since I am connected directly across these points, I will maintain a difference of 10 volt. Upper point will be at higher potential, lower point will be at lower potential, and I will maintain 10 volt difference across this 10 ohm. Now what this source will say? This source will say that my value is 20 volt. I will maintain a difference of 20 volt between these 2 points. So according to this source, this voltage difference has to be 20 volt, and according to this source, this voltage difference has to be 10 volt. So there is a contradiction, there is a fight, and between these 2 points, 2 voltage differences cannot be there. It can be either 10 or 20. You cannot take both the resistance, or you cannot add them. Okay, so the problem here is there is a fight. This source is saying that I will not do any compromise and I will maintain 10 volt difference. This is saying I will maintain 20 volt difference. So actually there is a fight, and nature does not like fight. Nature don't like fight. So the nature will say, because the nature is the most powerful thing, the nature will say that this circuit is violation of basic law. This cannot happen. You cannot connect 2 voltage sources of different value in parallel. Okay, so the nature has given us a law. Nature has given us a law. And what is that law? You cannot, 2 voltage sources of different value cannot be in parallel. 2 voltage sources of different value cannot be in parallel. Cannot be in parallel. Okay, you have to remember that. 2 voltage sources of different value cannot be in parallel. I hope it is clear. So this is the first law about the voltage source. What if superposition used? Okay, I'll tell you. Many students are thinking that, sir, why can't we apply superposition? Because some students have studied superposition. So can't you calculate this current using superposition? Answer is no. You cannot calculate. Why not? Let me tell you why. Let's say I have a source. Voltage source of 20 volt. Can you sort this source? Tell me, guys. Can an ideal voltage source can be sorted? Tell me, is it possible? Can you sort this voltage source? Answer is no. Again, there is a fight. Why there is a fight? Because this sort point will say that the voltage difference between the point A and B has to be 0 volt. And this source will say, since I am connected directly to this A and B, so the voltage difference between A and B has to be 20 volt. It means this voltage source is saying that this voltage difference has to be 20, and this sort point is saying that this voltage difference has to be 0. It means, again, there is a fight, and nature don't like fight. So nature is saying that an ideal voltage source can never be short circuited. So the next point is voltage source, ideal voltage source. Voltage source can never be short circuited. Okay, because it will violate the basic law. Now many students are thinking about superposition because they have studied superposition in 12th class. Okay, now if you are applying superposition, then you have to sort it. You have to take first source at a time, one source at a time, and you have to deactivate the other source. It means, let's say you are taking 10 volt source. You are taking 10 volt source at a time, and you are sorting this source. Voltage source is short circuited. Now tell me, is it a valid circuit according to nature, according to law of the nature, according to basic laws? Is it a valid circuit? Answer is no. It is not a valid circuit. It is not a valid circuit. Why? Because on this side, the voltage difference is 0 volt. So this side will maintain a 0 voltage difference, and this side will say that the voltage difference has to be 10 volt. So again, there is a fight. You cannot do it. Okay. So there is a violation of basic laws. That's why you cannot apply superposition in this case. I hope it is clear. Okay. I hope it is clear. So remember these 2 points. Now, many students are saying, some students are saying, or maybe after some point, after some time you will get a doubt. Sir, but we have a batteries, na? And we can take two different source, two different voltage value, two different value of, voltages for the batteries. Let's say there are two batteries. One is of 12 volt and one is of 6 volt. Can't we connect them in parallel? Answer is yes, you can connect them in parallel. There is no problem in the batteries. Because the batteries are not the ideal sources. If you want to represent the battery, then the battery can be shown like this. Let's say it's a 20 volt battery. So the 20 volt battery can be shown like this. This is some internal resistance of the battery. And there is some 12 volt battery. So there is one more 12 volt battery. Okay. And now if you want to connect them in parallel, you can easily connect them. Because if you are connecting them parallel, then this 12 volt and this 20 volt are not in parallel. Remember, these two sources are not in parallel. Why not? Because their lower point is same, but the upper point is not same. There is some resistance in between. I hope it is clear. So you can connect two batteries in parallel, two batteries of different value in parallel, because battery means something else. Battery doesn't mean ideal source. Okay. I hope it is clear. Tell me, guys. I hope it is clear. Okay. So two voltage sources of different value can never be in parallel, and a voltage source can never be short circuited. Okay. Now many students are thinking, sir, what will happen if I connect two sources like this? One source of 10 volt like this and one more source of 10 volt like this. Is there any problem? Can I connect like this? Yes, you can connect like this. Let's say this is 10 ohm. Now what about this current I? What about this current? How to calculate this current I? Sir, battery ka fir se. Okay. Let me repeat this. Battery is not an ideal source. Battery has some internal resistance. So this is a battery representation. So we have a 12 volt battery like this. So 12 volt battery can be represented like this, and a 20 volt battery can be represented like this, and a 12 volt battery can be represented like this. Now you can see that if you connect them in parallel, there is no problem, because these ideal sources are not in parallel. There is some internal resistance in between. They are not in parallel. Okay. And I am discussing about ideal sources. These conditions are valid for ideal sources. So remember this point. I hope it is clear. Okay. So you can connect two batteries in parallel. There is no violation. There is no violation of nature's law. But now look at this. Let's say there is ideal voltage source and there is one more ideal. Both have same value. Now tell me, what is this current I? What is this current I? What is this current I? Tell me, guys. Yes, it's 1 ampere. Why? Because this source will say that I will maintain 10 volt difference between these 2 points, because I am connected directly. Similarly, this source will say I will maintain a difference of 10 volt because I am connected directly. So both the sources are agreed on 10 volt. They are agreed on 10 volt. It means the upper point will have a higher potential, lower point will have the lower potential, and the difference is 10 volt. Now according to Ohm's law, the current will flow from upper point to the higher potential to lower point potential, and it will be 10 divided by 10. That has to be 1 ampere. Now many students are thinking that you can add them, the two voltages. 10 plus 10. 10 will give 1 ampere, this 10 will also give 1 ampere, and it will be 2 ampere. No. Why you are adding these voltage sources? Are they in series? Why are you adding them? Okay. Answer is 1 ampere only. Because this source will also maintain 10 volt, this source will also maintain 10 volt. It doesn't mean that it will be superposed. No. There can be only one voltage difference between these 2 points, and it will be 10 volt. Both are agreed on 10 volt. It means the voltage difference between these 2 points is 10 volt. So according to Ohm's law, 10 divided by 10, it will be 1 ampere from higher potential to lower potential. Okay. So the current will go from upper point to the lower point and it will be 1 ampere. I hope it is clear. Tell me, guys, is it clear or not? Now let's say one more circuit. Let's take one more circuit. Let's say this is 10 ohm and there is a 10 volt source. Okay, with this polarity, upper point is at higher potential, lower point is at lower potential, and there is one more 10 volt like this. Is it possible? Tell me, guys. Is it a possible circuit? Is it a valid circuit? Tell me. Is it a valid circuit? Tell me, guys. Is it a valid circuit? Tell me, everyone. Is it a valid circuit? Say yes or no. Tell me, everyone. Is it a valid circuit? Is it a valid circuit? Tell me, everyone. Is it a valid circuit? We have 10 volt like this. We have 10 volt like this. Again, it's invalid circuit. Why it's invalid circuit? Tell me, guys. Because there is a fight. There is a fight. This source will say that I will maintain 10 volt difference. And the 10 volt has to be of this polarity. This point has to be upper point, higher potential. This point has to be at lower potential. And the difference has to be 10 volt. What about this source? This source will say that I will maintain 10 volt difference but with opposite polarity. Now there is a fight. You cannot have two voltage differences. You cannot have two voltage differences between 2 points. There can be only one value, either 10 or minus 10. Okay, so there is a fight. There is a fight and this is not possible. So you don't take it equal. These sources are not equal. If it is 10, it has to be minus 10. We call it minus 10. And these two voltages are not equal. That's why they cannot be in parallel. So this is invalid circuit. I hope it is clear. I hope it is clear. Tell me, guys. Lake Prasad is saying cancel each other. No. I mean, I think you have not understood the concept then. If you are saying that they will cancel each other, it's a wrong statement. The circuit is invalid because this will maintain this polarity, this will maintain opposite polarity. You cannot have two different polarities across 2 points. Okay, if the points are same, there can be only one voltage. Okay, so the answer has to be invalid circuit. You cannot calculate this because this is 10, we call it minus 10. With respect to this voltage source, with respect to this polarity, it is opposite. That's why I'm calling minus 10. So they are not equal actually. 10 and minus 10 are not equal. Okay, that's why they cannot be in parallel. I hope it is clear, guys. अगर सीरीज में होते तो सीरीज में अभी देखेंगे हम लोग, पैरेलल को समझिए पहले. ओके, सीरीज पे मत बढ़िए, अभी पैरेलल को देखें. तो वोल्टेज सोर्स का मैंने आपको बताया that how the voltage source will behave and what are the conditions of voltage source. Okay, so voltage source will only maintain the voltage difference. It will not, it doesn't care about the current. Current can be anything from plus infinity to minus infinity. Okay, so current can be anything, and an ideal voltage source can never be short circuited because it will violate the basic law. Okay, I hope it is clear. Now let's discuss one more point, series connection. Okay, wait a minute. Okay, now okay, is it clear? Is it clear now? Tell me. Okay guys, sorry that there was a glitch. Okay, so there was a glitch in the camera, but let's come back to the screen. So let's say there are some elements like resistance, inductance, capacitance, BJT, MOSFET, diode, whatever element is. If the current direction is shown to you, let's say this is the current direction I. Here the current direction is like this. Here the current direction is like this. And the current direction is like this. The current direction is like this. And here the current direction is like this. Remember one point. If the current direction is shown to you, then the direction in which the current is entering in the element, that you have to take plus. And the other you have to take minus. Similarly, in this inductor, if the current is entering on this side, this has to be plus, this has to be minus. Because according to Ohm's law, there will be a voltage across this resistance. Na? If current is flowing in the resistance, then the voltage difference across the resistance will be R into I. Okay? According to Ohm's law, V is equal to IR. Okay? So that voltage difference will be developed across this resistance, and the polarity has to be like this. Wherever the current enters, that point will be plus. Wherever it leaves, it will be minus. Similarly, in this inductor, similarly in this capacitor, it enters here, so it will be plus here and it will be minus here. Okay? In BJT also, wherever the current enters, this will be plus. Wherever it leaves, minus. In MOSFET also, wherever it enters plus and wherever it leaves minus. In diode also, so this has to be the polarity. Remember this point. Wherever current enters, that point will be plus. Wherever it leaves, that point will be minus. Okay? But this is not valid in sources. Let's say you have a voltage source. In voltage source, current can be in this direction or it can be in this direction. Polarity is independent. Okay? In sources, you cannot apply this convention. This convention is valid in elements. Elements like resistance, inductance, capacitance, BJT, MOSFET. Okay? But this is not valid for sources. In sources, the polarity will be provided to you. And the current can be outside or inside. Okay? Because many students think that, sir, if the current is leaving from this point and entering at this point, then this lower point has to be plus, na? Okay, so this is not valid for the sources. Remember this point, guys. This is not valid for the sources. In sources, polarity is already given. It is independent of the current direction. Okay. Yes, it is independent for dependent sources also. It is not dependent on anything. Okay. In sources, we will not apply this condition. Remember this point. Whether it is dependent source or independent source, it doesn't matter. Okay. Because the polarity of the sources will be already given to you and it will be independent. It will be independent. Okay. Now, there is one more point that I want to tell you. There is one more point that I want to tell you, and that is, if you are going from minus to plus, let's say you have a voltage source like this. Okay, and the voltage source value is 20 volt. Just remember one point. If you are going from minus to plus, just add the voltage difference. This is the voltage difference between these 2 points. Since you are going from this point to this point, let's say you are going from upward direction. You are going in the upward direction. If you are going from minus to plus, you have to add the voltage. Because you are going from lower potential to higher potential. Higher potential means you have to increase the voltage. That's why it will be added. Now, there are some teachers and there are some books in which this convention is opposite. What they say is, let's say this point is X. If you are going from, if you are entering in the minus sign, they will say that you just subtract it. Okay, because you are entering in the minus sign. But I am not following that convention. Because I am following according to the nature. The nature says that since you are going from minus to plus, what does it mean? It means the voltage is increased. You are going at the higher potential. If you are going at the higher potential, then the voltage has to be increased. So if it is X volt, then this point has to be X plus 20. Okay? Is it clear, guys? So remember this point. I am following the opposite convention that the other teachers are following. Now, it might be possible that you are studying network theory from me and you can study analog electronics from some other teacher. It may be Rathi sir or it may be some other faculty. Okay, Ankit Joshi sir. And if you are lucky, then I will also teach you analog electronics. But let's say you are studying analog electronics from Rathi sir. So Rathi sir follow the opposite convention. It is not wrong. I'm not saying that it is wrong. Okay. But the thing is, I am following the nature's rule. And the nature says that if you are going from minus to plus, then the voltage will be increased. Voltage will be added. Okay. Voltage will be added. Okay. That's the thing that I follow. If you are going from plus to minus, it means the voltage is down. The voltage is decreased. So you have to subtract the voltage. Okay. Remember this point. Okay. I hope it is clear, guys. In case of resistances also, let's say you have a resistance. You have a resistance of 10 ohm. And let's say this is 1 ampere. So according to this direction of the current, what will be the polarity, guys? Tell me, what will be the polarity of the voltage across this resistance? This will be at plus, this will be at minus, and the voltage value will be 10 volt. Okay. I hope it is clear. Now, if you are assuming that this level is at 0 volt, what about this level? Can you tell me the voltage of this level? Can you tell me the voltage of this level, guys? According to Ohm's law, this voltage has to be I into R. There has to be 10 volt. And the polarity should be like this. Now, if this level is at 0 volt, can you tell me the level of this voltage? Since you are going from minus to plus, you have to add it. It means this has to be 10 volt. Now, many students think that, sir, if I am going like this, I have to subtract the voltage. No, I am going from lower point to the upper point like this. If I'm going from minus to plus, I have to add the voltage. It means this has to be 10 volt. And this is logical. It is according to the nature law. Why? Because the nature says that resistance will always give you the drop in the direction of current. If you are going in the direction of the current, then resistance will give you the drop, voltage drop. Drop means something down. It means if this is 10, then if you are going from plus to minus, you have to subtract this voltage. There is a drop. If there is a drop, then you have to subtract it. Nah. I hope it is clear, guys. I hope it is clear. That's why I'm following this nature rule. If I'm going from plus to minus, I have to subtract. If I'm going from minus to plus, I have to add. There is one more point. Why I'm adding it? If I'm adding it, this will be 10 volt for sure. And we know that in resistance, current flows only from higher potential to lower potential. If it is at higher potential, if it is 0, then the current will go downward. No? So that is also logical. I hope everything is understood. Okay? Everything is clear here. I am following the nature's law. But there are some faculty, there are some teachers which follow in opposite way. Whenever they are entering in the positive sign, they write the voltage as plus. They add it. Okay? I don't follow that. Okay? So please be careful, guys. Whenever you go from minus to plus, you have to add it. Because you are rising. Okay? You are increasing the voltage. Whenever you are going from plus to minus, you have to subtract the voltage. Okay? I hope it is clear. In KVL, we will understand it more. Okay? We'll understand it more clearly. Okay? I hope it is clear, guys. Now, let's come to the series connection of the voltage sources. Let's say there are two voltage sources which are connected in series. Let's say there are two voltage sources which are connected in series. Now tell me, if this is 20 volt, this is 10 volt. Is there any problem? And let's say this is 0 volt. Let's say this level is at 0 volt. I have provided you this level. Let's say this point voltage is 0 volt. What about this point voltage? And what about this point voltage? Tell me, guys. If you are going from minus to plus, you have to add the voltage. Okay? So this voltage has to be at 10 volt. What about this voltage? Since again you are going from minus to plus, you are going upward direction. So you have to add this voltage. So it will be 30 volt. So you can see that between these 2 points, the voltage difference has to be 30. These sources will be added. These sources will be added. And the voltage, total voltage difference between these 2 points is 30 volt. And there is no violation of the law. There is no, because you cannot say that this will maintain, this will maintain the 10 volt difference between these 2 points only. This point and this point. It will maintain a difference of 10 volt between these 2 points only. And it will maintain a 20 volt difference between these 2 points only. So there is no interference. There is no problem with that. There is no fight. There is no fight here. Okay. So whenever the two sources are connected like this, the voltage will be added. Okay. And the total difference will be 30 volt. If this is 0, this has to be 30. If you assume that this is x, this will be 10 plus x, this will be 30 plus x. Okay. This will be 30 plus x. I hope it is clear, guys. Okay. So I hope it is clear. Now, let me tell you one more important point. Let me tell you one more important point. So you have to be careful in those points, okay? Let's say you have sources like this and you have a resistance like this. Okay? Let's say this is 30 volt and this is 40 volt and this is 10 ohm. Tell me about this current. What is this current, guys? Tell me about this current. Apply Ohm's law. Okay? Now, let's assume that this point is at 0 volt. Let's say this is grounded. If it is at 0 volt, what about this point voltage? Can you tell me, guys? What about this point voltage? Tell me, everyone, what about this point voltage? Now, these sources are connected in series. These sources are connected in series. Tell me, what about this voltage? This voltage is minus 30 volt. That's correct. Minus 30 volt. Okay? This voltage is minus 30. What about this point voltage? What about this point voltage? Minus 30 plus 40. So it will be 10 volt. Okay? This will be 10 volt. It means at this point you will have 10 volt. And at this point you will have 0 volt. It means that this is at higher potential, this is at lower potential. So current will flow from higher potential to lower potential. According to Ohm's law, the voltage difference is of 10 volt. Upper point voltage minus lower point voltage. So the voltage difference is 10 volt. Divide by the resistance value, the current will be 1 ampere. Current will be 1 ampere. I hope it is clear, guys. So the current will be 1 ampere. Is it clear? Tell me, everyone. Okay. So this upper point, so whenever two sources are connected in series, there is no problem, there is no fight. You can add them or subtract them according to their polarity. Okay, according to their polarity you can add them or you can subtract them. I hope it is clear. Whenever the two voltage sources are in parallel, you have to be more careful. In parallel they have to be the same value. If the two sources are in parallel, they have to be of the same value, otherwise you can't connect them in parallel like this. This is wrong. This is invalid circuit if the two sources are not equal and they are connected in parallel. Now let's come to the current source. Now let's come to the current source. And I am telling you about the independent voltage source. Okay, remember, dependent voltage source I will take care in the nodal part. Okay, now let's come to the condition of current sources. Let's say you have a current source. Let's say you have an independent current source of 5 ampere. What does it mean? It means that it will maintain a current of 5 ampere value. It will maintain a current of 5 ampere value. Whatever branch in which this current source is connected, in that branch, current will be fixed at 5 ampere. It will take 5 ampere and it will give 5 ampere without compromising anything. It will not compromise anything. Okay, without compromising, it will take 5 ampere, it will give 5 ampere. It means current is fixed at 5 ampere. Okay, so whenever there is a current source in any branch, the current of that branch will be fixed and that current will be equal to the current source value. I hope it is clear. Okay, it doesn't care about the voltage across the source. It will say that the voltage across me can be anything. Let's say this is 5 ampere, so it will fix the current only. It will take 5 ampere, it will give 5 ampere. Okay, this is the only condition. It doesn't care about the voltage across this source. Voltage can be of this polarity, voltage can be of this polarity, it doesn't matter. And voltage can be of infinite level. It doesn't matter, that part also. Okay, so it don't care about the voltage. Voltage can be anything, but current is fixed. Okay, so remember this point in current source. I hope it is clear. Now, if you understood the condition of current source, let's try to connect some current sources. Let's say you have a current source of 5 ampere and let's say you have a current source of 6 ampere and there is a resistance. Now tell me, what is the current in this resistance? Tell me guys, what is the current in this resistance? Tell me everyone. There is a 5 ampere current source and a 6 ampere current source and I want to calculate this current I. Tell me the value of this current I. What is this value I? Tell me guys, and don't forget to like this session. Please like it. Okay, tell me guys, what is this current? Tell me guys, what is this current? Abdul is saying 11. Okay, dark current. Okay, your name is itself current. Okay, dark current is saying violation, not defined. Okay, Senthil is 11. Okay, Prabhakar 11. No, answer is invalid. Why it is invalid circuit? Because there is a fight. This source will say that I will 6 ampere and I will give you the 6 ampere without any compromise. I will take 6 ampere, I will give 6 ampere without any compromise. This source will say, I will take 5 ampere and I will provide 5 ampere without any compromise. Now look at this point. This source is saying, I will provide you 6 ampere without any compromise and I am not ready to compromise. This source is saying, I will not take 6 ampere, I will take only 5 ampere because this is my condition. The nature has given me some power. Nature have given me some authority. And that authority, according to that authority, I will only accept 5 ampere. Now, there is a violation at this point. What is the violation, guys? Tell me. What is the violation, guys? This is providing 6, this is taking 5. Where that extra 1 will go? There is no way to go. Okay. So it's an invalid circuit. So nature says that there is a fight here and I don't like fight. Nature doesn't like fight. So nature will stop this condition. Nature will say that the two current sources of different value can never be in series. Okay. So the two current sources of different value different value can never be in series. Okay, two current sources of different value can never be in series. I hope it is clear. Okay, but if they have the same value, then it is possible. Let's say there is a current of 5 ampere, current source of 5 ampere, and there is one more current source of 5 ampere, and I connect a resistance here. Now tell me, what is this current value I? What is this current value I? Now there is no violation. Now there is no fight. Why there is no fight? Look, this current source will say, I will accept 5 ampere and I will give 5 ampere. Okay, without any compromise, I will take 5 ampere, I will provide you 5 ampere. The upper current source is also saying that I will take 5 ampere and I will provide 5 ampere only. Okay, I will provide 5 ampere. It means this current has to be 5 ampere. Only 5 ampere will go on this side. And there is no violation here. Okay, there is no violation here. Sir, will it be invalid even if there is a resistance in between two sources? Yes, it doesn't matter if you connect a resistance in between here. Because if you connect a resistance like this, let's say there is a 5 ampere like this, and there is a resistance and there is a 6 ampere here. Again, there is a violation. No? There are series. In series, you can take any element before the, there is no way, there is no rule that resistance has to be connected here only. You can move the resistance to any place. This is a series connection, and this connection is equivalent. Okay, you can take this 10 ohm out of these two current sources, or you can connect this resistance like this, no problem. So again there is a violation. Why there is a violation? This will accept 6 ampere, it will provide you 6 ampere. So 6 ampere will go in the current source, but here only 5 ampere is accepted. Now where that extra 1 ampere will go? Okay, so the problem is this. So again it's an invalid circuit. I hope it is clear. Prabhakar, sir, voltage difference is required to flow the flow of current. How heavy current flow in short circuit which has zero voltage difference? Yes, that's a good point. Now Prabhakar is saying if any circuit has 0 ohm resistance, then if I want to flow the current, if let's say there is a zero resistance path, and I want to connect a source to flow a finite current in this has to be finite. Okay, and the R is 0, we know that. And if you want to flow a finite current, what should be the source value? What should be the voltage source value such that this current become finite? Okay, I think this is your question. Now the answer is it has to be 0 volt. With the help of 0 volt, if the resistance is 0, you can get finite current. Now it's a hypothetical situation. You will ask me, sir, why? Because we know that I is equal to V upon R. If R becomes 0, if R is 0 and you want this current finite, how it is possible? Tell me guys. How it is possible to get this current finite with R equal to 0? The only condition is V becomes 0, such that it will become 0 by 0. If something becomes 0 by 0, we call it indeterminate form. And whenever 0 by 0 form occurs, we apply limits. If you remember, L'Hopital rule. We apply L'Hopital rule. Okay? And with that, with the help of this, you can get finite value. Okay? So remember this point. It's a very valid point. If resistance of anything is 0, then you have to apply a 0 voltage difference to get the finite current. Okay? I hope it is clear. But if the voltage become finite, if the voltage is not 0, let's say the voltage become finite, let's say voltage is V naught, then the current has to be infinite. Okay, you will get undefined current, infinite current. Okay, so this is the problem. We call it indeterminate. Okay, if we call it infinite, okay, you'll get infinite current. You get infinite current. I hope it is clear. Okay, so you will say, sir, but it is hypothetical situation. Yes, R0 itself is a hypothetical situation. It means the first step is hypothetical. If you are asking R equal to 0, then you are asking me a hypothetical question. That's why I am giving you a hypothetical answer. Okay, so it's equalization. Okay, I hope you understood. Anyway, so let's come to the next thing. So I told you I told you about current violation. Okay, so two current sources of different value can never be in series. Two current sources of different value can never be in series. Okay, sir, can I add two current sources in series? No, you cannot add two current sources. You'll understand in KCL. I'll teach you about KCL. Then you will understand that current sources will be added only in case of parallel. Like voltage sources. Now, voltage sources can be added in series. Okay. Similarly, current sources will be added in parallel connection, not in series. In series, if they are connected in series, then they cannot be added. Okay. Because there is a violation. No? How can you add them? If you are taking equal current, let's say this is 5, this is 5, this is not 10 ampere. You can see that this will allow only 5. It will take only 5. It will give 5. It will accept only 5. It will give 5. So only this current has to be 5 ampere. It will not be 10 ampere. So how can you add them? Logically, you follow the logics. Na? How can you add them? This will allow only 5 ampere. So 5 will go again. 5 will go outside. Okay. Okay. Is it clear, guys? V और R दोनों 0 को 10 करेगा ना सर. That's why the current will become finite, ना Pradyuman. Okay. Okay. You are saying that in this situation, R cannot be 0. R should approach 0. Okay. If R should approach 0, then V should also approach 0 to get finite current. Okay. If R should approach 0, then V should also approach 0 to get the finite current. That's my answer. Okay. I hope it is clear. Manohar, sir, can I add two? I have given you the answer. You cannot add two current sources in series because you have to follow the logic. If this is 5, this will accept 5. This will accept 5 from here. This will give 5. The upper current source will also accept 5 and it will give 5 ampere to this. So it means on this side only 5 ampere will flow. How can you take it 10 ampere? Okay, so I have given you the answer. I hope it is clear. Let's move ahead, guys. Let's move ahead. So I told you that current sources of different value can never be in series, but they can be in series if they have the same value. If they have the same value, you can directly calculate this current. This current has to be 5 ampere. I hope it is clear. Okay. Now let's mix them all together. Now let's take current source and voltage source in one circuit. Okay. But before that, I want to ask you one more thing. Let's say you have a circuit. Let's say you have a circuit like this. Okay. And I take a current source like this. Can I open circuit this current source? Can I open circuit? Is it a valid circuit? Can I keep this current source open? Tell me. Can I keep this current source open? Tell me, everyone. Can I keep this current source open? Tell me. Can I keep this current source open? Can I keep this current source open? Answer is no. Why not? Because the basic law will violate. There is a fight again. This is invalid circuit. This is invalid circuit. Why it is invalid circuit? Because the current source says that I will accept 5 ampere and I will give 5 ampere without any compromise. Without any compromise, I will accept 5 ampere and I will give 5 ampere. Now, if this is open circuited here, where this current will go? I mean, the path is broken. Okay. So the current cannot go beyond that point. Okay. So that's an invalid point now. The current has to be 0. According to this open circuit, this current cannot flow. This current has to be 0. But the current source is saying that I will not compromise. I will give you 5 ampere. So there is no way to flow that 5 ampere. So this is invalid circuit. So the law is you cannot open circuit an ideal current source. Ideal current source can never be open circuit. Current source can never be open circuited. Okay, can never be open circuit. It's similar to voltage source. A voltage source can never be short circuited and an ideal current source can never be open circuited. Oh, I hope it is clear. Okay, guys. Okay, so I told you about current source, I told you about voltage sources, ideal voltage sources. Remember, I am discussing about ideal, non-ideal I am not saying. Battery is a non-ideal voltage source. Okay, I am not considering non-ideal voltage source. I am considering only ideal voltage sources. Now, let's mix them together. Now, let's connect current source and voltage source all together in a circuit. Okay, so let's say I have a circuit like this. There is a 10 volt voltage source and there is a current of 5 ampere, and let's say this is 1 ohm. Tell me this current I. Find I. Find I. Tell me guys. We have a current source and a voltage source. Different current sources cannot be in series. Yes. Different current source can be in parallel. There is no problem in parallel. Okay. If the two current sources of different value are connected in parallel, there is no problem at all. Okay. You'll apply KCL at that point. I'll teach you how. Don't worry. But before that, let's look at this circuit. Tell me this current I. How to calculate this current I? Tell me guys, what is this current I? Do it fast. Let's see how many of you can solve it. Do it fast. What is this current I? Tell me the value of this current I. Tell me, what is this current I? Okay. So now you can see that there is a current source and a voltage source. Now let's apply the conditions. Current source is saying that I will take 5 ampere and I will give 5 ampere without any compromise. Okay. It is saying that in this branch, current has to be 5. Okay. And I'm happy with that. If the current remains 5, I have no problem at all. Now, what this voltage source will say? This voltage source will say that I am connected directly with these 2 points. Between these 2 points and these 2 points. I have connected directly. I am connected directly. So, I will maintain a difference of 10 volt between these 2 points and between these 2 points. I will maintain a difference of 10 volt. It means across this 1 ohm, voltage difference has to be 10 ohm. Okay, this is ohm, 1 ohm. Okay, across this 1 ohm resistance, voltage difference has to be 10 ohm, 10 volt. It means this upper point will be at higher potential, lower point will be at lower potential. So the current will flow according to Ohm's law in downward direction, and it has to be 10 upon 1. Okay, so I has to be equal to 10 ampere. Is it clear, guys? I has to be 10 ampere. It means in this side, 10 ampere will flow. But does it violate any condition? Does it violate any condition? Answer is no, it's not violating. Why not? Because look, this will say that I will give you 5 ampere, okay? And on this side, 10 ampere is going. So extra 5 ampere will come on this side, okay? 5 plus 5 will make 10, and 10 will go in this branch. I hope it is clear. So no law is violated. This source is giving 5 ampere. This source is saying, I don't care about current. Current can be anything from me. Current can be anything from me. I don't care about the current. And this source is saying, I don't care about voltage. Whatever voltage across me, I have no problem. This source is maintaining 10 volt across it. This current source is saying, I don't care about voltage. Voltage can be anything. So no problem. With this voltage source, there is no problem. Okay. So there is no violation with this current source. It is providing 5 ampere. It is going 10 ampere in this side. So the source will provide, this voltage source will also provide 5 ampere. Okay, so the total current will be 10 ampere that will go in the resistance. I think there is no violation, and this current has to be 10 ampere. Okay, now there are some students who will ask me, sir, what will be your answer if you remove this current source? Then also your answer will remain same. Let's say this is 10 volt and this is 1 ohm. Now can you tell me about this current? Tell me about this current. What is this current, guys? Tell me. Now can you tell me about this current? What is this current? Tell me guys, what is this current? According to Ohm's law, this is higher potential, this is at lower potential, this has to be 10 ampere. Okay, this has to be 10 ampere. It means the answer will remain same. So why I have connected a current source here? Why can't I remove this current source? Whenever a voltage source and current source are connected in parallel, everything will be decided by the voltage source. Because if you connect a resistance here, the voltage source will decide the current in the resistance. Then what is the purpose of this current source? Why can't you remove that current source? Actually, you can't remove that current source. Why? If you are removing this current source, in this resistance, everything remains same. The voltage across this resistance is 10 volt. Previously, it was 10 volt. Okay, and the current is 10 ampere. Previously also it was 10 ampere. So nothing has changed as far as this resistance is concerned. Okay, everything remains same. But this circuit and this circuit are not same. Why not same? Because of power. Whatever power this source is consuming, whatever power this resistance is consuming, in this circuit the entire power is supplied by this source. But in this circuit, the total power which is consumed by this resistance is not supplied by this voltage source only. Actually, this current source is also participating. That's why you cannot say that this circuit and this circuit are equivalent to one another. But there are some teachers, they teach you that whenever voltage source and current source are connected in parallel, you can always remove this current source and connect it like this and calculate the current value and the voltage across the resistance and the power in the resistance. Actually, that is wrong. As far as this resistance is concerned, no problem. You'll get the answer. Logically, you'll get the answer. No problem at all. And your answer will be correct. But this answer is not actually, conceptually it is not correct. Okay. Because you have done some conceptual mistake. Okay. I hope it is clear, guys. I hope it is clear. So don't do this step. But as far as resistance is concerned, to calculate the answer, you can always apply this rule. Okay. There is no problem. If you are only concerned with the answer. Okay. If you are only concerned with the answer, if you want to calculate the answer only, then whenever the voltage source and current source are in parallel, you can replace this branch with a voltage source only. And you can calculate the current in the resistance. There is no problem at all. As far as the answer is concerned. But conceptually, this is wrong. Because in this circuit, the entire power consumed by this resistance is supplied by the voltage source. But in this circuit, the entire power which is consumed by this resistance is not supplied by this voltage source only. Current source will also participate in the power. I will tell you how the current source will participate. How much current this source will deliver or absorb. It can deliver or it can also absorb the power. So, but it will participate in the power. How it will participate, we will discuss that. Okay. So I hope it is clear, guys. I hope it is clear. And I hope this question is also clear. In first case, 10 volt lasts longer. It's not about last longer or last maybe. Okay. It's actually about concept. 10 volt will decide everything, because this voltage source will say that I will maintain this voltage difference, I will maintain this voltage difference. If the voltage difference across resistance is fixed, then the current will also fixed according to Ohm's law. Okay. So simple. Now let's come to one more situation. Let's come to one more situation. And in that situation, what I'm doing is I'm connecting a voltage source and current source in series. Okay. Wait a minute. Now my slider is not working. Okay. Okay. Yes. Now let's take a voltage source and a current source in series. Now can you tell me, let's say this is 10 ohm. Here you have 5 ampere. Here you have 20 volt. What about this current I? Find I. Tell me about this current I. Tell me, guys. What about this current I? Okay, we'll discuss about power later. Don't worry, Abdul. We'll discuss power in a later section of the class. Okay, I mean the next class we'll discuss about power. But before that, please try to solve this question. Find I. Tell me, guys, what is this current I? What is this current I? Yes, the current I has to be 5 ampere. Okay, this current I has to be 5 ampere. This current source will say, I will accept 5 ampere. I will give 5 ampere. It means in this circuit, in this branch, in the entire branch, current is fixed. Only 5 ampere will flow on this side. Okay. So I has to be 5 ampere. And there is no violation of any rule. This voltage source will maintain a voltage difference between these 2 points. Between these 2 points, voltage difference has to be 20 volt. And it will maintain the current. It will not care about current, because current is going in this direction. 5 ampere is going in this source and it is going in upward direction. So it will not care about current. The voltage source will say, I don't care about current. Current can be anything. It can go from me, or it can enter in my positive side. I have no problem with the current. So current, it doesn't care about the current. That's why the current will go like this, and current will remain at 5 ampere. I hope it is clear. Tell me, guys. So this current has to be at 5 ampere. Now, there are some students who think that, sir, if I make a circuit like this, 10 ohm, and there is a current source of 5 ampere like this, will it be okay? You'll get the same answer, no? I is equal to 5 ampere. You'll get the same answer. If you if you remove this voltage source and you connect the circuit like this, then again, as far as this resistance is concerned, you'll get the same answer. Current is 5, the voltage across this resistance is 50 volt, and the power loss in this resistance is again same, okay? It means you are getting the same answer. You are getting the same answer. So is it correct? Is it correct to remove this voltage source? Answer is no. As far as this resistance is concerned, if you want to calculate voltage or current or power in the resistance, there is no problem. You can remove this voltage source. Whenever a current source and voltage source are in series, you can always remove this voltage source if you are concerned with the answer only. An answer in the resistance. Let's say you want to calculate the resistance current or resistance voltage or resistance power. Then you can always remove this. There is no problem at all, as far as the answer is concerned. But conceptually it is wrong. Why conceptually it is wrong? Because in this circuit, whatever power is absorbed by this resistance, that power will be shared by these two sources. But in this circuit, the entire power is delivered by the current source only. That is the main difference. That's why conceptually this circuit and this circuit are not equivalent, not equal. Okay. But as far as resistance is concerned, you can always apply that. So remember this. As far as this resistance is concerned, if the voltage source and current source are in parallel, you can replace it with a voltage source only, as far as the answer is concerned. And if the voltage source and current source are connected in series, you can always replace with a current source. Okay. I hope it is clear, guys. Okay. So let's stop the class here. And in the next class, we'll discuss about KCL, Kirchhoff's current law, and KVL. Okay. So in the next class, we'll discuss about KCL and KVL, guys. So it's time to stop the class. It's time to stop the class. So tell me. Okay. Rajsri Joshi is saying, wait. Okay. I'm waiting. You want to ask something? If you want to ask something, you can ask me. Tell me, guys, is there any doubt? Is there any doubt? Please ask. How was the class? How was the class? Have you understood all the concepts? I'm getting confusion in series and parallel resistance. Okay. If you are getting confusion in series and parallel, then please watch the class again. Whenever two resistors are connected back to back like this, we call it series. Okay. And you can add them. Whenever the resistance have same starting point and the same end point, because it's a single point, it's a single point. They're starting at the same point, they're ended at the same point. We call them in parallel. So R1, R2 are in parallel. Okay. So you can connect them in parallel. Since in my semester exam in semester 3, now I am semester 6. I told you, no? You just revise the previous class in which I have told you that. Okay. I have told you that. And try to solve more problems. Yes, that's a good idea. Okay. Sir, sequence of electrical subject to be covered, batao. Network, then signal. Network, then signal. Then control. Then digital. Then EMFT. And after that, you can start with analog. Okay. So this is the sequence that you need to follow. Okay. After that, you can start with the core subjects. No problem. Okay. So this would be the sequence. Okay, guys. So I think I have taken all the doubts. Okay. Now it's time to stop the class. So if you have any doubt, you can reach to my Telegram channel, and the Telegram link I have given you in the description of this video. So you can go there, you can join that Telegram channel, and from that channel you can ask my own channel. Okay, because I have two channels, Telegram channel. One is that provided by the BYJU'S, and one is provided by, one is my own Telegram group. Okay, so I will also give you that link. So you can join that Telegram, which is given in the description. And after joining, you can ask me my own channel. Okay, I will also tell you about that channel. Okay, in series, same current flows, while in parallel, current gets divided. Yes, that's true. That's true. That's true, because in parallel, when whatever current is there, it will be divided. Okay, in series, there is no division of the current. It will go like this. Okay. आपके कितने पढ़ा रहे हो इसमें से? I'm not getting your point. Okay, so let's stop it here, guys. So thank you for showing interest in this class, and see you in the next class. Don't forget to subscribe our channel. Please like this session and press the bell icon if you have not pressed it. And there is one more thing, we have a mobile app also. So please install BYJU'S Exam Prep mobile app. Go to the Google Play Store and download it and install that mobile app. So there will be some free classes on mobile app also. So you can watch these classes also. And आप कितने subjects cover कर रहे हो? I teach almost every subject in electrical engineering. Okay, so let's stop it here, guys. So thank you, and see you on maybe the next class will be after Holi. So happy Holi to everyone, and see you in the next class. Next class will be after Holi, and it will be maybe on tomorrow, day after tomorrow. Okay, so see you then. Thank you and take care. Bye.